Hello, Chemistry. Mr. McKee here again with our next installment of the stoichiometry unit, in which we convert from moles to mass or mass to moles within an equation. So we're talking about products and reactants. And again, we're going to be focusing on coefficients and using mole ratios, but we're going to add into that something we learned earlier in the year, which is molar mass, which is information we get by using the periodic table and adding up the various parts of a compound. And I'll show you how to do that here in a minute. Okay, so let's jump right into our first example. How many grams of lead oxide, PbO, are made when 3.1 moles of oxygen are reacted? So again, the first step here is to underline the important components of the question. You might even want to circle those. So you've been given oxygen and you're trying to figure out, you've been given moles of oxygen and you're trying to figure out how many grams of lead oxide are going to come from that. So in this particular equation, we're interested in this part and we're interested in this part. And for this question, we can ignore these parts. They don't have anything to do with what we're trying to solve. So let me introduce you to something we're going to be using for the rest of the unit now, which is a stoichiometry roadmap. And this just sort of helps us take a forest view of what we're trying to accomplish here and kind of map out exactly what we're going to do. So in this case, we're trying to go from moles of oxygen. I always work from left to right on this. And we're trying to convert to grams of lead oxide. So if we work our way left to right in our map, what that's going to look like is we're first going to have to convert from moles of oxygen to moles of lead oxide. And then we're going to convert from moles of lead oxide to mass in grams of lead oxide. So that's our basic plan, and you can refer to that as you go through the problem here. All right, so once again, we're converting from moles of oxygen to moles of PbO, and finally into grams of PbO. So we are going to need to calculate the molar mass of lead oxide. And the way that we do that, you might recall from earlier in the year, is to take the components of lead oxide and simply add their masses together, and we get those masses from the periodic table. So we've got one lead in this compound, and we've got one oxygen. The mass of lead is 207.2, and the mass of oxygen is 15.999. And when you add those together and round appropriately, and we're not too worried about rounding at this point in the year, you get 223.2 grams. So that's the only molecular mass we need to add up. Later on in the unit, you'll see why we have this other space over here. We'll need to use that, but for these problems here that you're learning about today, we don't need to use that space. So let's move on now and let's set things up. So remember what our plan is. First, we need to convert from moles of oxygen to moles of lead oxide. And the ratio is for every 3 moles of oxygen, I have 2 moles of lead oxide. And again, I get that from the equation. 3 moles of oxygen for every 2 moles of lead oxide. So that's going to allow me to convert to moles of PbO, but then I need to convert to grams of PbO. And the conversion factor I'm going to use for that is what we calculated here. So that is 1 mole of PbO is equal to 223.2 grams of PbO. So I should have written down my starting number. That is what I got from the question, and it was 3.1 moles of oxygen. and I am trying to figure out how many grams of PBO will form from 3.1 moles of oxygen. So that's grams of PBO is my ending unit. All right, so we have two conversion factors, so we are going to need to do a two-step problem here. As always, we're going to put our starting number in unit right here. Not grams, it should be moles, so 3.1 moles of oxygen. And my first step, and I do like to go in sequence here using my roadmap, is I want to convert from moles of oxygen into moles of PBO. So I'm going to use this conversion factor. I'm going to put oxygen on the bottom since I'm trying to cancel it out. So 3 moles of oxygen is equal to 2 moles of lead oxide. And again, that allows me to cancel out moles of oxygen. But I'm not done there. I now want to convert from moles of lead oxide into grams of lead oxide, and I'm going to use this conversion factor. 1 mole of lead oxide is equal to 223.2 grams of lead oxide. Let's do some canceling. Moles of PBO cancel because they appear on both the top and the bottom. And now I've arrived at my ending unit, which is grams of PBO. Now I'm ready to plug everything into the calculator. So the way that I'm going to do this is I'm going to take 3.1 times 2 times 223.2 divided by 3. Then I hit enter at the very end. And what I should get is 461.28 grams of lead oxide. So I just figured out that in this equation, if I start with 3.1 moles of oxygen, I will end up with 461.28 grams of lead oxide that are made. Okay, pause the video and see if you can do the U-try. Welcome back. For the U-try, we're using the same equation, but the question is different, so let's read the question carefully. We are trying to find the number of moles of PBS that are required to react with 10 grams of oxygen. So the parts of the equation that we're interested in now are both of the reactants. Lead sulfide and oxygen. So now I'm going to fill out my roadmap. And in this case, I'm starting with grams. So I'm going to start over here on the far left. I always work left to right. And I'm going to put 10.0 grams of, and actually I don't even need to put the numbers in there. I can just put O2 because this is sort of our forest level planning. And we're going to convert from grams of oxygen into moles of oxygen. We're going to use the molar mass to do that. And then we're going to convert from moles of oxygen into moles of PBS. And we'll be done because that's what we're trying to figure out. So you'll notice, you can picture this dividing line here. You always change from one chemical to another when you cross that dividing line, from moles of one thing to moles of another. All right, so let's calculate the molecular mass of oxygen. We've got 2 oxygen atoms, each with a mass of 15.999 grams. So when we add those together, we're going to end up with 31.998 grams. So that is the mass of 1 mole of oxygen. That's going to be one of our conversion factors down below. Let's keep going down here. Again, we're interested in these parts of the equation. For this particular question, we can ignore the products. So my starting number is 10.0 grams of O2. I get that from the question. And I'm trying to figure out the moles of PBS. So going in order, using my roadmap here, step one is to convert from grams of oxygen to moles of oxygen. So the relationship between grams and moles for oxygen is 31.998 grams equals 1 mole of O2. So that's going to allow me to convert to moles of O2. Then I'm going to have to convert to moles of PBS, and I'm going to use the relationship between the two in the equation. So for every 3 moles of oxygen, I'm going to have 2 moles of PBS. And now I'm ready to plug things into the train tracks down here. So as always, my starting number goes down here. And again, I'm going to go in sequence. So my first step is to convert from grams to moles of oxygen. So I'm going to put 31.998 grams down here. That's grams of O2. That's equal to 1 mole of O2. This allows me to cancel out grams of O2. And now I'm going to convert from moles of O2. It's not 1 mole, it's actually 3 moles of O2. And for every 3 moles of O2, again, we have 2 moles of PBS. Arranging that conversion factor allows me to cancel out moles of oxygen and leaves me with moles of PBS for an answer. So now we're ready to plug everything into the calculator. As always, we're going to times on top and divide down. We're going to do everything in one kind of straight line. So I take 10 times 2 divided by 31.998 divided by 3, enter. And that's how you solve these problems, the best way to do it anyway. And the answer you should get, and again, we're not too worried about rounding at this point in the year, is 0.21 moles of PBS. So if you want to react 10 grams of oxygen as described in this equation, you are going to need 0.21 moles of PBS. Remember that the answers for these practice problems are given to you in parentheses. Good luck and have a great day.